Here we move away from the mathematics of finance to the mathematics of population and income growth. Now we'll find that we're going to use similar tools of analysis because in each case we're looking at what is happening over time. We begin with the growth of population and income over time. As you may have seen in the first film, the world's population was once thought to be growing at an unsustainable rate. In fact, while it's forecast to keep growing rapidly in some areas of the world, it's actually expected to decline in Europe. In the UK, birth rates are too low to keep the population rising, but immigration may well make up for this, and means that it might well grow by around 1.5% per year in the foreseeable future from its current level of about 60 million. Does this mean to say that over time we're going to get worse off? Well, not necessarily, because although the population is growing, the amount of output we're producing is also increasing. Output is rising at somewhere close to 3% per annum. So what's going to happen to living standards over time? We can use our mathematics to do the calculations. Here we want to know when the two economies will have the same average income per head. In each case, we've got a geometric series with an unknown, n, which is what we're looking for. And in our case, n has to be the same. That is, we need to find n, the number of years from now, that both economies will have the same average income. So looking at Slovenia first of all, the current average income is 18,000 per head. So in n years' time, with a growth rate of 3.2%, we'll have 18,000 times 1.032 to the n. The EU average income is substantially higher at 25,000 euros per head, but the growth rate is slower. So in n years' time, the EU's average income will be 25,000 times 1.015 to the n, because we've got a growth rate annually of 1.5% only. So at what point will the two be equal? Well, it's the point when 18,000 times 1.032 to the n equals 25,000 times 1.015 to the n. How are we going to solve for n? Well, one way is to divide through by 1.015 to the n, and that will give us 18,000 times 1.032 to the n divided by 1.015 to the n equals 25,000, which is the same as 18,000 times 1.032 over 1.015 all to the n equals 25,000. Now if we divide through by 18,000 and simplify, we have 1.0167 to the n equals 25,000 over 18,000, which equals 1.3889. Now we can take the log of both sides. So the log of 1.0167 to the n equals the log 1.3889. And now using our rule of logs, n log 1.0167 equals log 1.3889. So n equals log 1.3889 divided by log of 1.0167, which solves at 19.84. So it will, on the above assumptions, take Slovenia almost 20 years to reach the EU's average income. Now here we have a similar problem to solve for Poland. We've got a lower starting level of average income, but a faster growth rate. That is, a higher scale factor. But we can solve in the same way as before. 9,500 times 1.05 to the n, the Polish average income in n years' time, equals 25,000 times 1.015 to the n. That's the EU average income in n years' time. So 9,500 times 1.05 to the n over 1.015 to the n equals 25,000. 1.0345 to the n equals 25,000 divided by 9,500, which is 2.6316. Now we'll take logs. Log 1.0345 to the n equals the log of 2.6316. So by our rule of logs, n log 1.0345 equals the log of 2.6316. So that n equals the log of 2.6316 divided by log 1.0345, which comes out at 28.53. So although Poland has a faster growth rate, its low current income level means that at these projected growth rates it will be almost 29 years before it reaches the EU average. So it's possible to solve for n where n is a power appearing on both sides of the equation. In the context of country growth, it enables us to see how quickly two economies will converge. For Eastern and Central European economies converging on the EU average, it appears depressingly slow despite their relative dynamism. If you believe the assumptions that we're making are wrong, well, it's easy for you to recalculate, making your own assumptions.